So we've talked about types of forces. Our big forces, we have gravity. All right, but then we also have the electrical force, the magnetic force, the weak nuclear force, and then the strong nuclear force. And as we went along, we found out that the electrical and the magnetic and the nuclear, weak nuclear, are all functionally the same, and that's the electroweak force. But that's it. All forces are one of these kind of three, and that's it. What we think of as a regular push or pull is either gravity, the electrons repelling in our hands, bats, pens, pushing things around with our hand. The electrons in my hand are repelling the electrons in the pen. That's what's moving it around. But we can also categorize forces by not only their types, but also their direction. So let's take a look at our first directional force. Our first directional force points perpendicular to a surface. So here's my little guy. He's laying on the paper. When he stands up, he is now pointing this way, pointing up out of the paper. His direction is normal to the paper. Another word for this is, it's another word for orthogonal. Orthogonal. All right. So, which way is the paper pushing him? The paper is pushing him this way. It's pushing him normal to the plane of the paper. If I tilt the paper, all right, now it's pushing him that way. Now it's pushing him that way. So, when we have normal to paper, this is perpendicular to the plane of the paper. So when you have a table, and you have a box on the table, let's look at the forces that are on that box. So you have the force of gravity coming down. Gravity is pulling it down, but it's resting on the table, so the sum of the forces, it's not accelerating, has to equal ma. Ma is 0, so the sum of the forces have to equal 0. If this way is positive, the sum of the forces equal negative the force of gravity, but I have to have something else in order for me to get to 0. Something else has to be pushing it up. It's the force of the table. But what direction is that pushing? What direction is the table pushing? It's normal. So we will often call that a normal force. So, force of the table plus the normal force gives me 0, which makes sense. But what about when we're on a slanted table or on some sort of... So when we have, here's our box. So now gravity still pulls down. However, our ramp is shifted. The force of the ramp is in that direction. It is normal to the surface. Remember, normal is a direction. It's not a different force, it's a direction. The table is pushing normally. The ramp is pushing normally.